Hey folks, I wanted to give you a run through of calculating beam size as well as joist size in the building code. So this is just kind of used as a practice question, and hopefully you can follow these steps to solve some of the other problems that I've given you to practice with. So we'll start with our supported joist length. Now if you remember, our supported joist length is how much of the floor the beam is actually carrying. So oops, that's the wrong picture. That is, looking at this picture is a good one. So remember that the beam is only picking up a portion of the floor. In this case, with one beam running down the middle, the beam is picking up half the floor on this side and half the floor on this side. So it's picking up half the floor. So a really simple way of doing this is taking the total width of your building and then dividing it by 2. Now we could take into account some other things like our mud sills and things like that, but from my experience, it hasn't really made a huge difference. So what I would do is just take the width of your building divided by 2. So let's go and have a look back here. So here the width of our building is is 7.77 meters, right? So that, if we take that divided by 2, we get 3.89 meters is our supported joist length, okay? And we'll see why that's important here in a second. So 3.89 meters, okay? So how many posts do we need? So we're gonna try and figure out how many posts we need. And so we do this, we're just gonna kind of spitball. We're just gonna give it a try and see what we can get away with here. So our total building width is 10.89 meters total. That's to the outside. So remember, we're going to have to go to here and subtract our foundation walls off of that. Okay, so remember that our bearing point ends at our foundation wall. So what we want to do is completely subtract our foundation wall off of both sides, and that will tell us how much total clear span we have from inside a foundation wall to inside a foundation wall, and that will help us figure out how many individual spans we have from post to post. So let's have a look over here. We have 10.89, okay? So what we're going to do is we're going to subtract our foundation wall. So our foundation walls are 200 millimeters thick. Okay, so we'll take 200 millimeters off of this side and 200 millimeters off of this side. So 10.89, we're going to go minus 0.2 minus 0.2, which is just 200 millimeters converted into meters, since we're dealing with meters. And we get 10.49 meters. Okay, so we're going to take our 10.49, and let's let's just try to put one post in there. Okay, so we have one post. That means we have 2 spaces, 2 spans to deal with. When we do that, oh, I just realized I erased my number here. 10.49 divided by 2, we get 5.2 meters, right? 5.25 meters. Okay, so 5.25, let's go over to the building code and see if we can make this work. Let's get rid of that for a second. So we'll go to the building code, and let's go down here, floor joist still. Okay, so beams supporting not more than one floor. So for this example, we were using spruce pine fir, SPF. We were using number 1 or 2 grade, so we're going to be in these rows. Okay, so this is the potential. Everything else in the chart doesn't matter. Now, our supported joist length was 3.89 meters. That's our supported joist length. So with that, we're going to come over here. 3.6 is not big enough, so we'll go to the 4.2 row. So now we can choose any one of these beams, right? And now we said that when we put one post, that gives us 2 spans of 5.25 meters. So let's look along here, 5.25, we don't have it. So by process of elimination, we know that we're going to have more than one post. So now let's take I'll change my color here. Let's take our 10.49, which was inside a foundation wall to inside a foundation wall, and we'll divide it by 3 spaces this time. And that we get 3.5 meters. Okay. Okay, so 3.5, let's see if we go down the row here, 3.02, 3.44, so close. Okay, so we have here 3.84, oh, 3.46 doesn't work. Oh, and we have this, 3.99. So we could choose a 5-ply 2x10 or a 4-ply 2x12, and we'll have 3 posts. Okay, or sorry, 3 spaces, that's 2 posts. Right, so let me go back to the foundation and look at this for a second. Go here. So that means we're going to have 1 post, we're going to have 2 posts, we're going to have 1, 2, 3 spans or 3 spaces. So our supported joist length was 3.89. How many posts do we need? We need 2 posts. 1, 2. Okay, and what size beam will we use? Either a 5 by 2 by 10 or a 4 by 2 by 12. Deeper is normally cheaper, but we'll see. We'll show you this in class of how it's cheaper. What is the clear span between posts? So what is the actual spacing from post to post to post to post down here in the basement? So to do that, we already figured out from inside a foundation wall to inside a foundation wall was 10.49 meters. So now, all we need to do is subtract our posts to get the actual span between the posts. So, we take our 10.49, and our posts says right here, telepost with 152 by 152 plates will be used. So what we're going to do is subtract 152 here and 152 here off of our 10.49, and all we'll be left with is the actual measurements of the span. Okay, so let's see that. Minus 0.152 minus 0.152, and we are going to get 10.186 meters. So that is the total span. Now we know we have 1, 2, 3 spaces, so we're going to take that number and divide it by 3, and we get 3.395. I'm keeping it to 3 decimal places here to be more specific. So this would be 3 meters and 395 millimeters. Okay, so if you wanted a very precise measurement there. So what is the clear span between the posts? 3.395 meters. What is the max clear span according to the code? So depending on whether we used a 5 by 2 by 10 or a 4 by 2 by 12, that will tell us what we can use in the code. So let's go back and have a look at the building code. So according to the building code, we were in this row, okay, and we said we could use a 5 by 2 by 10 or a 4 by 2 by 12, okay? Those are the 2 options. So if we went with the 5 by 2 by 10, the max span would be 3.84 meters. If we went with a 4 by 2 by 12, our max span would be 3.99 meters, so a stiffer floor. So you could choose either one there. You'd be right in both circumstances. All right. Now, what size joists will we use? So if we're looking at our joists, so our floor joists span from the inside of our mud sill to the inside of our mud sill, okay? And if we want to be really specific, we can also subtract our beam off of that to figure out. So when we're calculating the clear span of our joists, if you want to be really specific, you can go from inside of mud sill to inside of beam, and inside of beam to inside of mud sill. I've noticed that this doesn't change too much unless you're really, really tight, you're very close with something. So normally what I do is go inside of mud sill to inside of mud sill, but let's be specific here just for the sake of covering all of our bases. So our joists are running in this direction, right? So our joists are running across like this. We know that we're going to have a 4-ply or a 5-ply beam running here. So what we're going to do is we're going to subtract our mud sill on this side, subtract our mud sill on this side, and subtract our beam. Okay, so we have in this direction 7.77 meters minus our mud sills are 140 millimeters wide. They're 2 by 6. So minus 0.14 minus 0.14. Now our beam is either a 4-ply or a 5-ply beam. So there's two options here. We could either subtract for a 4-ply or a 5-ply, and a 5-ply beam would be 190 mils, and a 4-ply beam is 152 mils. Now I'm going to just go with the 4x2x12 for this, but I bet you that it wouldn't make a difference whether we did the 190 mils or the 152 mils. But here, let's go minus 0.152 meters. Okay, and we get a total of, when we subtract all that out, we get 7.34 meters. So our total span from inside a beam to inside a mud sill, 7.34. Now we have 2 spaces, so we're going to divide this by 2, and we're going to get the actual span that our joists need to go. So that's 3.67 meters. So our joists have to span from mud sill to beam 3.67 meters. So that's the number we're going to go take to the building code to see how that works out. So let's have a look at the building code here, and we're going to have to go to our different chart. And we're looking at our floor joists for general cases. Now we're going to be using spruce pine fir, so we're down here, and we're also going to use number 1 and 2 grade. So we're going to have a choice in here. Now on this particular floor, it says we're going to use strapping and bridging. So right away, we eliminate most of the chart by looking at this. Now I've also told you that we're pretty much never going to build at 300 on center, which is 12 inches on center. It works, it's allowed by the code, but we're really not going to do that very often. So really, our choices are in these 2 columns. So now we're looking for, I'll remind you here, 3.67 meters is how much our joists have to span. So we can look, and we've got a couple options here right off the hop. So we have 3.72 and 4.0. So we could choose, let's bring this across, a 2x8 at 400 or 16 on center, or we could choose a 2x10 at 600 or 24 inches on center. So again, you have a choice here. So we could do either or, 2x8 at 16 on center or a 2x10 at 600 on center. Depends on how stiff you want your floor. All right, so what size joist we're going to use? It's either a 2x8 at 16 inches or a 2x10 at 24 inches. Okay, now how many sheets do we need to cover this floor? So very simply, the floor, we're going to calculate the total area of this floor. We have to subtract for our floor opening because that's a significant size, and we'll see what we have left. So very simply, we're calculating area here, so 7.77 times 10.89, and that gives us 84.62 meters squared. So that's the total area of this floor. Now I said we have to subtract that floor opening, so that floor opening is 1.02 times 2.11, and that we get an area of 2.152 meters squared. So now we're going to subtract minus 2.152 meters squared, and we get a total area of flooring that we need to cover 82.47 meters squared. So that's how much we need to cover. Now the question is how much does 1 sheet of plywood cover? So we've said that if one sheet of plywood is 4 feet by 8 feet. Okay, so what we can do is we can convert these numbers into metric. Okay, so now I know that when we convert this out, right, so you can do it in millimeters or whatever you want to convert it. Personally, what I would do is I would go 48 inches by 96 inches, and I would go each number divided by 25.4, okay? And you'll get for 48 inches equals 1,220 millimeters when you round it. And I mean, based on that alone, you could just do the 48 and multiply this by 2, or you could do both numbers. But the 96 inches is equal to 2440 when you round it. It's like 2438, but we always refer to it as this. So now, if we have this in millimeters, it's really easy to make this into meters. You just change that comma into a period. So now we have 1.22 meters and 2.44 meters. So 1 sheet of plywood is equal to 1.22 times 2.44, and when we do that, we get 2.98 meters squared. So 1 sheet of plywood covers 2.98 meters squared. So now we take the total area of our floor divided by 2.98 meters squared. And we end up with 27.67 sheets. Now, you can't have 0.67 of a sheet, so we're going to round up because we can't have 27 sheets. That won't be enough. We need more. That'll be 28 sheets of plywood. 28 sheets of plywood, and that is without waste. Of course, we'll add a waste factor to that, typically about 5 to 10%. And so if we did that, we could add, let's say 10%. So we could do that times the 27, so 27.67 times 1.1. I'll write this down. 27.67 times 1.1 equals 30.44. So we'll call that 31 sheets total to cover that floor. All right, guys, I hope this is helpful. I hope this is a good accompaniment to the practice questions that I'm giving you. Please let me know if you're having any trouble with this, and we could definitely practice this more in the class, and I'll see if I can help you maybe one-on-one as well. All the best. Take care.